User PLC. Elite Robot Conveyor Craft. Need counter module, rotary encoder, and microsensor. Elite Robot Conveyor Craft Sketch. Atom module configuration. Download and install Configure software. Double-click. Right-click Search device from Internet. Atom module connect to Internet. Scan automatically. At here, the address is 192.168.1.111. This address can be modified. Then let's do the necessary configuration. At this screen, we can see hardware version and module name. And this is basic network address information. We can modify it as needed. In Stream Interface, link the addresses of the PC host, or robot, in the same network segment. 111 is Atom module address. 110 is computer address. 200 is robot address. The default password is 8 zeros, generally, not modified. In Access Control, add addresses that control connections to other devices on the network. Here, 110 is computer address, and 200 is robot address. Check an input address. Click Apply. In Modbus address, we need configure the start bit of counter frequency. Here, we set it to 4000. After all the configuration is completed, double-click the 6051 module. Enter 8 zeros. We can observe the module in real time. Notice here, encoder ABC 3 wires connect to Atom module. In our example, these wires corresponds to DI5, DI6, DI7. DI5 is counter. DI6 is frequency. DI7 is also counter. Turn on the conveyor. At this time, the value of counter is increasing. This value can be corresponded in teach pendant. For the value of DI5, in teach pendant, DI5 is D010. Black, white, orange 3 wires correspond to ABZ. A is DI5, B is DI6, Z is DI7. Then there's Lua script. The first line, sleep, clear first. This IP is the address of Atom module. Port number 502. Here, make Modbus connection. This function counter is to get register address. This is 4009. It is little different from the value of configuration window. Configure 4000 here. We use Modbus to connect Atom module. Read register address. It's 4000. At this time, we find out there is a value in 4009. This value is correspond to D011 in teach pendant. D010 is the final result. D011 is the value under 65536. Therefore, D011 plus 65,536 is D010, also is the last result of encoder. Now we keep going Lua code. Here, 4010 can be deleted. We read the value of the 2 bytes register of the Atom module at once. Return retlist. When the value of encoder do not over 65,536, we can assign the value of his first register directly to D11. D12 is whether encoder exceeds the number of laps. This is 2 laps. So now the result is 2 times 65,536 plus D11 equals D10. The result of 10 is obtained after calling getCounter. From getCounter, we can get the encoder data from conveyor and can be assigned to POS0. POS0 is directly assigned to D10. So D10 is the final result. Now let's start conveyor calibration. Click Extension, Lua script. Run the script first. Quit this window. Then Extension. Track, parameter setting. Choose craft number. We have 8 craft number, 1 to 8. At here, we choose 7. Function selection. Track. Endpoint set 400. You can change these parameter based on the real case. Next, click Start Calibration first. Let's turn on the conveyor. Check the value of conveyor is or not return. The value will store in D9, 10, 11. Turn on the belt in a low speed. It's easy for us to control. Determine the coordinate system in the right place. So at here, we determine point A. Move the robot to the specified preset cusp. After aim the point, determine point A. Recorder point. After determine point A, we need to set the location of tracking. Open JBI. We set the point A into P0. And we set a prepare point above P0, and record into P1. Then we set 3 track points, the edges of this box. Record in P10. We set the second one. Notice to the range that the robot can reach while moving. Fit as closely as possible, so that it can be more accurate. Record in P11. Then the third point. Record in P12. The last point. We record this box as a rectangle. Record in P13. Then, we set a wait point. Wait point set P1. Add move LP10. We track P10, 11, 12, 13, and P01 is the above point. Since our craft number is 7, therefore, we set track 7, and track N7. Track time we do not need to set, if we need stay relatively stationary in a track point, like grip or grab a stuff. Then we need a synchronized time, otherwise, we do not need to set a track time. Then turn on the conveyor again. The distance between point A and point B as long as possible. We move robot to point B. Aim at cusp, be as precise as possible. Record point B. Point A and point B can determine X, then we need to determine Y. We choose a point in XY plane. Record as refer point. Click Calculation. Calibration successful. The proportions can be seen here.